Okay, in this session we are going to derive an expression for a refraction through curved surface. That is, we're going to derive an expression for refraction through curved surface in order to get the exact place where I have to stop. I'm putting two dots and let me draw it over here. This is our curved surface. That is, we are considering a curved surface over here. This is our curved surface, and in this curved surface let's draw our principal axis. This is our principal axis, and on the principal axis let me have an object or a point object which is placed on the principal axis, and let's initially assume that a light ray is traveling from this object and it is passing through the principal axis. That light ray will pass without any deviation since it is passing towards the center of curvature. A light ray which is in the direction of center of curvature will pass without any deviation through the refracting substance. Therefore, it's passing like this. Then we're taking the next ray. The next ray is a light ray which is starting from the object and it is passing like this. Now considering this light ray, it's not passing through the principal axis, therefore it will bend or it will refract. And in order to draw the path through the denser medium, before drawing that, I'm marking a point over here, and this point is marked as C. Can you imagine what C is? Yes, C is center of curvature. Then a dotted line from the center of curvature to the point of incidence of the green ray. It is our normal. Let me write it as normal. This is the normal. Therefore, this angle is angle between incident ray and normal. It is angle of incidence I. This light ray is trying to move from N1 refractive index medium to N2 refractive index medium. That is trying to move from rarer medium to denser medium. It will bend towards the normal. Therefore, instead of continuing that path, it will bend towards the normal. It will move like this and it will ultimately converge over here, and at this point we will get our image. This is object, this is image, and let me mark what is this distance. This is the distance from curved surface to the object, therefore it's marked as u. And what is this distance? It's the distance from image to the curved surface. It is v. V. Can you see it? It's v. Then the distance from curved surface to the center of curvature, it is our radius of curvature r. Okay, we are having u, v and r. Then let's mark this point as our point P. What is this angle? This angle is angle between normal and refracted ray, therefore it is angle of refraction r. It's angle of refraction r. For our calculation purpose, we are making an angle like this, that is angle between principal axis and the incident ray. It is denoted by alpha. We'll be using it in our calculation purpose. And this angle, the angle between refracted ray and principal axis, it is marked as beta. Hope you can see it. It is beta. And the angle between normal and principal axis, it is marked as gamma. This is r, this is gamma. Okay, then After marking all these things, consider a triangle OPC. The triangle OPC. In that triangle, I is the exterior angle. By the exterior angle theorem, exterior angle is the sum of its interior angle. Therefore, we could write I is equal to alpha plus gamma. I is equal to alpha plus gamma. Then from a triangle CPI, can you see a triangle CPI? From triangle CPI, gamma is exterior angle and R and beta is interior angle. Therefore, gamma is equal to R plus beta, but we require an equation for R. Therefore, I am retaining this R is equal to gamma minus beta. Let me write it like this: R is equal to gamma minus beta. We know I and R. Then what is Snell's law? Snell's law, we know it is sin I by sin R is equal to N2 by N1. That's our Snell's law. But in this case, since I and R is very small, therefore what could write is, therefore we could write sin I is approximately equal to I and sin R is approximately equal to R. We could use this approximation if angle is very small. Okay. Therefore, this equation can be written as I by R is equal to N2 by N1. I by R is equal to N2 by N1. And what is I? I is alpha plus gamma. What's R? R is gamma minus beta. Substituting for I and R, alpha plus gamma divided by gamma minus beta is equal to N2 by N1. Okay, cross multiplying N1 into alpha plus gamma is equal to N2 into gamma minus beta. We're getting an equation like this. On expanding this equation, we will get N1 alpha plus N1 gamma is equal to N2 gamma minus N2 beta. We're getting an equation like this. Then taking gamma to one side and bringing this minus N2 beta to the side, we will get the equation as N1 alpha minus N2 beta is taken to the side means plus N2 beta is equal to, there is an N2 gamma over here, and if I am taking this N1 gamma over here, it will become minus N1 gamma, and we are taking gamma out, gamma into N2 minus N1. We are getting an equation like this. Then we are going for another approximation, that is, if alpha, beta and gamma are very small, and I and R is small means alpha, beta, gamma, it will be also very small, and in this case we are using the approximation alpha, beta, gamma are very small. We could write tan alpha approximately equal to alpha and tan beta approximately equal to beta. Tan of gamma is approximately equal to gamma. The reason is alpha, beta, gamma are very small. We could approximate like this. But can we find out tan alpha? Not from this diagram. Therefore, in order to find tan alpha, let me take a thinner pen. I am drawing a perpendicular like this. Hope you are seeing a perpendicular like this. I am drawing a perpendicular like this, and I am marking this point as N. Can you see that point N? Then from the triangle OPN. What's tan alpha? Tan alpha is opposite side, that is PN by adjacent side is ON, and it is approximately equal to U. Then tan beta can be obtained from the triangle like this. Tan beta is opposite side Pn by adjacent side is actually Ni, but we could approximate it as V. Then tan gamma. Tan gamma can be obtained by the triangle CPN. CPN, tan gamma's opposite side is Pn, adjacent side is NC is approximately equal to R, therefore Pn by R. Then alpha is Pn by U, beta is Pn by V, is Pn by R. Therefore this equation can be rearranged as N1 alpha is Pn by U plus N2 beta is Pn by V is equal to, let me write this, N2 minus N1, N2 minus N1 into gamma. What is gamma? Gamma is Pn by R. On seeing, we could cancel out this Pn, then it will become N1 by U plus N2 by V is equal to N2 minus N1 by R. And this is not the end. By sign convention, U by sign convention it is negative. V, we can see V is positive, and R, sign convention wise, R is also positive. V is negative, U is positive, R is positive by sign convention. Therefore this equation can be written as this minus N1 by U is taken to this side, that is I am writing N2 by V U negative minus N1 by U is equal to N2 minus N1 by R. This is the formula for refraction through curved surface if a light ray is traveling from rarer medium to denser medium like this. Okay, N2 is refractive index of the denser medium, N1 is refractive index of the rarer medium, U is object distance, V is image distance, R is the radius of curvature.